Thanks. We'd like to thank you all for inviting us to come here, and we want to talk about our project here. And I've got Dr. Phillips here with me, and he's the scientist of the project. I'm Louis Eaton, and I'm the rancher here where we actually have the project set up, and we call it managing rangelands for natural carbon capture. And there's our main thing. I should tell you that Jesse Becker is with the North Dakota National Resource Trust, and he's the administrator of this project. And what we want to try to find out is why we want to find out more about carbon. We want to find out why it's important in North Dakota. We want to find out how we measure carbon. I've been in rotational grazing and watching the development of grass and cattle for like over 20 years, and we know certain things that we've learned along the line. Like we do get more forage production when we have a good managed grazing program where we rotate. We have changing season of use where we have better we have more wildlife habitat and water quality. There's a whole lot of things that we've seen develop over the years. But the thing about the carbon is, probably until 5 years ago, I didn't really know very much about carbon, and there's still quite a bit to learn about it. But it is a really interesting part of our industry now. And carbon capture in rangeland is it is probably something that's can be financially benefit to ranchers and help to preserve rangeland.
And so he came to me like 3 years ago and said, well, how do you measure this carbon? How do we do it? And so I was really surprised, and he wanted to know how much the instruments cost. How can we get this done? And it was rather surprising that a rancher would be that interested in, scientific work. So that's how we started the conversations. And with Jesse's help, we worked together on proposals of the proposal until finally, eventually we got this project funded, which was essentially to test this idea of, does our rotational or our managed grazing affect the amount of carbon dioxide that's taken up and sequestered in the ecosystem? So we needed to be able to do an experiment in the field using a herd of cattle that rotates and measure the carbon dioxide that's going in and out of that system continuously over time in order to be able to figure this out. It was a rather challenging experiment. But like Louis says, this is when you talk about carbon in rangelands, you're talking about soil carbon usually that's in the ground and is getting stored there naturally. And he thinks if he's getting more production, grass production with his grazing system, then naturally there would be more carbon, right, coming into that system. So see, that's what we endeavored to find out. It took a lot of work on everyone's part, but where this project is basically set up to address this particular question using the most high-tech scientific instruments available, the gold standard that are used worldwide. And like Louis was saying, this project in his mind is more than just about carbon and the value of carbon as a resource, but also, there's the soil health benefit of having more carbon in your soil. There's the economic benefit of having a more productive rangeland. There's the habitat benefits, pollinator benefits. There's the legacy, what you're leaving behind to future generations. And then, of course, possible of voluntary markets where we can increase the rangelands will have more value if carbon is considered a resource of value that they can get paid for every year. That's what is being done right now. But Louis, being the businessman that he is, he wanted to know, well, I want to know exactly how much carbon is coming into my ground so that I know what I'm selling if I want to sell it. So that's what we're investigating here. Now I'll real quickly say, have to go through a little bit of the technicalities of carbon itself and the ways that we measure it. And all of them are great ways, but what we're doing, and I want to show you just for the distinction, right? So you can take a soil sample and you can, like Trey was talking about, and you can measure the organic matter or the carbon in that ground. And then you can come back 5 years, 10 years, 15 years later, and you can look for a change, right? If you see a change, then you're going to be able to see, oh, I'm gaining more carbon. But the tests that we use to do that are measured in terms of parts per 100, right? So we're limited by how well we can take a piece of soil, burn it, and capture the carbon gas that comes from that in order to tell you exactly how much carbon is in there. Now, another way to measure carbon, which is measured in parts per million, is when we actually measure the molecules of carbon dioxide in the air. So the carbon that you're getting in the soil is a solid carbon, right? It's organic matter. What we're measuring out at Lewis's place is a gas. It's the gas that the plants take up when they photosynthesize, turning it into the organic matter that they put in the ground. So we're basically getting very high frequency measurements using this system called an eddy covariance system. And it's when we do that, we're measuring the net ecosystem exchange. So inside this ecosystem, say 50-acre area, we're getting carbon dioxide coming into the plants. We're also getting carbon dioxide coming off when the microbes and other things breathe, right? So all this is happening at the same time. And the net flux that we get every half hour, that net number is what's left. Do we have more coming in or more coming out? During the daytime, more is going to go in because the plants are out there photosynthesizing, right? And at nighttime, they're not photosynthesizing, so you might see more carbon dioxide coming off of the soil when it breathes, right? That's respiration. So anyway, we're also measure water vapor and everything, but this is what you call the state-of-the-art way of measuring it, because we can tell you right now, within a week, 2 weeks, 3 weeks, we can tell you what's going on a daily basis. We don't have to wait 5 or 10 years to look for carbon in the ground, right? So this is one of the benefit of it. So if you want to know a management impact, you can more easily see that management impact within a short period of time. And the main thing to just want to keep in mind, this is ecosystem respiration. So we're getting data from over here, over here, over here, over here, over this 50 acres constantly. And we're getting it at 10 measurements a second. But we're getting it for the whole area, not just a single point. But the conditions have to be right for this measurement. So it takes, and you have to have an entire year of data to really get the whole picture of what's going on, to put it all together. So what we get at the end of the day is an annual ecosystem carbon sequestration. How many pounds per acre of carbon dioxide that was retained or sequestered in that ecosystem. So that's the important in my mind, that people, when you hear so much about carbon, that you understand that, because on the voluntary markets, they're talking about metric tons of CO2 or carbon dioxide in the air, that form of gas. When they talk about pipelines of carbon going down, carbon dioxide from ethanol plants, they're talking about carbon dioxide, right? And because plants turn carbon dioxide into organic matter, we talk in units of carbon, right? Because it's organic matter carbon. So organic matter is a combination of a bunch of things that's carbon based. So if anybody has any question about that, don't feel free to ask if I wasn't clear enough. But at any time, please, I'll be happy to take it easy. And at the end of the day, we take this net ecosystem exchange, which comes from here, a whole year's worth, right? And then we take out what was harvested by the animals and what was deposited by the animals for in rangeland systems, in order to get the net amount of carbon that actually was retained by that ecosystem. So these are all the things I pretty much explained, that we have this is a sonic anemometer, 3-dimensional. We're looking at vertical winds, infrared gas sensor that measures the water vapor in the air, measures the carbon dioxide in the air. but we're also collecting a lot of other data because all the weather matters, right? We have to have precipitation, soil temperature, radiation. There's a number of different components to it. And so what we're going to show you when we get to our preliminary data is we're going to show you half-hour average measurements for that are collected continuously in these systems. So I'll leave it back to Lewis now. Thanks.
Thanks. This is what the this is what the pasture. This is a section of pasture land on my ranch, and this is what my paddocks looked like before we started this project. You can see there's 7 different paddocks, goes to the water source right in the middle of it.
So this is what you will call the system that before I came along.
Yeah, there you go. Okay. And then here, after when we decided to put this project in place, what we changed in this is the same. This is a picture of the same section of rangeland. You can see we put 4 paddocks there up on top, and then this instrumentation that we had here, that sonic anemometer and all the rest of the things are set in the middle of it, where and you have, these are about 11-acre paddocks, and that's about the range of what the instruments can sense. And it's we ran our projects tried to be as close to like a working project that you could have. We ran like 150 pairs in each one of these paddocks, and we did it one day a month or a day and a half a month. Tried to remove visually what we thought was 50% of the growth that we had there at that time. And we kind of actually we came pretty close when we got done with the clippings and the measurements. It was fairly close. And then you'll see on the bottom there's another 50-acre parcel of pasture that is a control, and that's not being grazed. And Rebecca will show you later on a graph, how the flux changes between the two of them as you go into the cycle of the grazing. And it's a 2-year project, and actually if we could have more, it would be better. It would, the more data you can collect is always beneficial. We're also measuring the leaf area and the biomass. So besides just the carbon part of this, I'm also learning a lot of things that we thought we knew, but now we can verify it about how much in forage poundage I actually removed, and at what time of year, and what kind of regrowth we got on it by the end of the year. And we alter the season of use, so we have a benefit for nesting area of birds and different things. And we're also tracking what percentage of what species are on these paddocks, and as we go into other years, we'll be able to tell if we've changed anything on the species percentages. And it's also and then of course we have the ungrazed part with the sensor down there that'll tell us the same thing on the
and this is one of the sites. There's 2 of them. They're instrumented the same. So this is what the entire array looks like. Solar power, the battery. We don't have hard power out here, so we have to have everything with the battery. We've got all the data logger, rain gauges, radiometers, the whole instrument all in there, and below ground things, measuring what's going on with the moisture and temperature and everything below ground. So that's a picture of what one of them looks like. And this is what the data look like. We deployed them at May 1st this year, and this is an example of a period of time where it's positive. That's uptake of the CO2, or where more carbon is coming into that system than is leaving it. So it's sort of a net amount coming in, and then at night would be when you've got release, where more carbon is leaving that system than is coming in. And this is the blue line is the control, and the orange line is and this is before we started anything. This is before we did any treatment at all. So we got at least a month of background data before we did our first graze. And like Lewis was saying, we do a graze on one of those paddocks around June 1st, a graze and another one on July 1st. another one on August 1st, another one September 1st. So we're trying to capture different seasons. And then the next year will come around and we'll vary which one is the first one grazed. That's altering the season of use, or what I call asynchronicity in grazing. But again, this is net ecosystem exchange of carbon dioxide. So this is your carbon dioxide stuff. And this is an example of what fence line of grazed area and ungrazed area out there. To see that, you know, after the grazing treatment, it usually took about 1.5 to 2 days of grazing with the 150 cow-calf pairs to get about 50% of that leaf area removed. But we had to be out there with them all the time. So this is 10 days after our first grazing treatment, okay? Now imagine that you've got the sensor here and the grazing treatment was over here. And so the wind was coming from over here at first, right? So you see that the blue and the orange lines are kind of really close to each other during that day. And then we have a release at night. And then the next day, the wind was coming from this direction where the grazing occurred, right? Now what we see is the blue line 10 days post-grazing is a little bit higher. There's a little bit more uptake in the control. Because why? Because the leaf area was removed, right? The leaves are like solar panels, and you deplete them, you're not going to get as much energy in. So this is an example of, okay, we're seeing wind is coming over that. It's picking up the carbon dioxide fluxes, and it's saying, all right, that removal of leaf area had a little bit of an effect on the carbon uptake. Bigger leaves, more uptake. This is 60 days post-grazing, again, with the wind coming out of up from that area. And now you're seeing the orange line is slightly higher than the blue line. So over the course of that recovery, now the grasses are recovering, the regrowth is really going strong, and you're seeing now a slight difference between the two lines. This is the 1, 2, 3, 4 days in would have been in early August. And so you could say, okay, we're starting to see some differences. No, it's not dramatic. And but this is why it takes a whole year of data and a lot of careful analysis. Here's September. Now we're seeing that difference between the orange line and the blue line growing. So the grazed system is actually taking up more. That recovery is happening, and we're seeing a bigger uptake, a bigger net ecosystem exchange of carbon dioxide is more positive from that. It's now we don't know whether we're going to see this every year. We don't know the whole story yet until we get a year of data, but it's telling us that, wow, there are some differences here. We're observing some things that might be interesting that we should need to take a close look at. And so one of the things we did when we talk about removing leaf area is we have to measure, well, did they remove 50% of the leaf area or not, you know, and where are we at with leaf area? And this is before each grazing event. In the dark ones are the control areas that we routinely take clippings from. And you can see, well, in June, our leaf area was around 1 for both of them. In July, leaf area was a little higher, but both around close to 2.5 in July. And then in August, the leaf area in the ungrazed or the control dropped quite a bit in August. And then it continued to drop in September. And then in October, the two of them were pretty close to the same. And do you know what I mean when I say leaf area? You know what I'm talking about? I'm saying we go out and we clip a frame, right? And then and that's a particular measurement size in that frame. And then we take all the green leaves that come in that frame and we run it through this little scanner, right? One at a time. and it adds up that area of that leaf in, you know, square inches, if you will, right? And then it tells you how much green vegetation is out there. Right, that's the area of solar panel, if you will, capturing energy and exchanging carbon dioxide. So when I showed this to Lewis, you know, you can see that the grazed one, the leaf area tends to be later on in the season tends to be a little higher than the control, right? And I thought, wow, that's really different, that you can see more leaf area over there. And he said, well, what you're doing in these grazing systems is you're extending the growing season. That's how he put it, which I thought was a nice way to say that we have more leaf area for more greater growth potential. And which, if you have more growth potential, you have greater capacity for carbon dioxide exchange and uptake. So this was not something that I would necessarily know would happen, but I think it kind of explains physically, the instruments are nice, to measure all this invisible stuff, but the leaf area is something that you can hold in your hands and you can go, oh, okay, yeah, there's just more area picking up and photosynthesizing, right? So, what I think is important that we try to tell our partners and our funding, or people that support this work, and when we're writing the proposals, is that why they say, well, why is this unique? What makes this important? And like Lewis says, this is a real working lands project. I'm not on some little area somewhere in a very controlled conditions. I mean, we're out there on a section of land. We're using a real comparable cattle herd, and it's really the first that I've seen of a managed grazing experiment to test what that is doing to the ecosystem carbon sequestration amount, so that annual amount of carbon that is sequestered in that ecosystem can be evaluated under managed versus unmanaged grassland, right? And we've got multiple stakeholders, multiple people involved, from industrial commission and oil companies and conservation groups. And I'm part of a nonprofit, ranchers like Lewis. They're all interested and engaged in this because they say, well, we've been seeing better grass when we do this. But we did it, but now we just need the data to see, are we sequestering more carbon? Because if that carbon now has a money value, we want to know what that is so that we can be sure and get more value for our land if that's the case. And do you want to talk about this?
Sure.
Okay.
This is a map this is like an infrared map of North Dakota, and it tells you the amount of, I would call it forage, that you can grow in the different, there's like 8 different zones here, and it's kind of interesting, it shows how diverse our state is and the difference in the grasslands from eastern North Dakota to central North Dakota, throughout to western and southwestern North Dakota, and you can see the change that goes across there. And as part of the thing to talk about the value that carbon might have to ranchers and to myself, there is a market for that now, and it's emerging. It's probably still in the growth stage, but there are contracts being written. I have personally received an offer. I haven't done it yet because it's very complicated, but it does have a lot of value to me, and what I'm looking at and how I can in the future. Since I have a ranch in central North Dakota and I have one in southwestern North Dakota, the project we're doing here should be able to model into the other project. And I know kind of what my values might be when if I want to pursue a sale of my carbon to a company. And right now the voluntary market is it's kind of I would call it a thin market. There's not a lot of action on it, but it's getting to be more acceptable all the time. And right now, the value is anywhere between $14 and $40 a metric ton. And I'm just going to throw a number out there. If you could sequester, a half a ton an acre, that would, if you got $40, $20. So an acre, and that that would have a lot of value in places. It is like I said, it's a very complicated thing, and anybody that I would recommend anybody that's looking at doing that would have it really looked at closely, because there's a lot of pages on the contracts, and of course it was written by the broker part. But it is interesting, and we got next step in that.
And well, I just wanted to also touch on, this is modeled production, right? And what we hope to do with, if this project were to continue, is we hope to be able to take the information that we're getting every half hour, all that weather information and all that carbon data, and create a model that we can apply to Western North Dakota. So that places that we have there's a rancher near Williston that is collecting a lot of leaf area and weather data, that where we could say, all right, we know the conditions and we know the importance of these variables based on all this really expensive data from the McKenzie ranch, and we want to turn around and model it for other areas with different weather patterns, with different kinds of grasses. And this is an example of an older model that doesn't take into account, anything to do with, and it's just above ground forage, but we're getting the carbon that's going in the entire ecosystem, right? So at the end of the day, this is just an example of a picture, but we want to be able to take it and model, use infrared data like this and model so that every year you can see for different areas in Western North Dakota, how much carbon dioxide, how much carbon was sequestered in particular areas, so that if you went as a tool for ranchers in a way, like Lewis was saying, for them to gain more value. So this is an example of what a larger scale map would look like. And eventually the data that we're collecting will be able to use towards that end. And we want to be sure and acknowledge the amazing support we've gotten, and of course Sarah Simmers with the work she's done with the plant species, the North Dakota Natural Resources Trust and Soil Conservation Districts, the Oil and Gas Research Fund. There's a number of partners that have made this possible. It's an incredibly time-consuming, difficult, technically challenging project, but boy, we really see it, and we hope you can see that there could be real value to not only to North Dakota, but for grasslands all over. When I first started, Lewis said, the cows aren't going to like you very much. Because he says, why aren't you out there, in June 1st when those cows are anywhere near those instruments, right? So I was there, wandering around, and then that's as close as I could get to them to take a picture, right? And because I was so nervous, we were all nervous. We didn't want the cows interfering or, running into the instruments, damaging them. This is kind of rather expensive. But at the last race, at the end, this is what I took a picture. They were much happier with me. And I think it was because I was holding the hose that was giving them water. They're like, all right, she's all right. So now they're not as scared from me anymore. And we really thank you. And we hope that we can solicit some questions from you. Yes.
Question for Lewis here. How did you normally treat those cells of paddocks that you had, or cattle numbers and durations?
I had along with that sectional land, there's other pastures there, and it was a large rotation.
But normally, how did you do it before this project to come on?
Well, they were larger paddocks, so they were probably in there for 2 weeks in a lot of them, and then moved to the next one. But usually just once during the season they would be in those paddocks, but they were larger. Like some of them were 200 acres. In that part.
Is that typical for most ranchers?
That would be probably somewhat smaller than the paddocks. I probably get a little more than the average ranch does, but been at a long time and see the benefits of it. So that's something that I worked hard on, is to we try to add pastures when we can, because as long as if it's a low cost, to add another paddock where it's just a little string of electric fence and you already have the water and you can just move your fence on one side of the water to the other, it's a big benefit without any cost, And same way with, when you talk about a carbon sale, if I were to make one, it's probably a fully net, whatever I would get paid would be a fully net profit, because I'm not changing anything. You know, my rotation and now that has been what I'm doing anyway. So it's a, you know, zero cost.
So my point is just how you think comparing day or day and a half or is gonna be to what rancher typically does.
Well, we only did the day and I'm not a terribly big fan myself of the day and a half. Limiting, you know, that small because of the labor involved in it, you know. I mean, people do it and it does have a little additional benefit, but what I see the difference between, you know, 1 or 2 days and a week, it's minimal. From, you know, whatever the grass production, you know, your carbon sequestration, it would be a small amount.
And if we could have set up the instruments to do a half section, if they were capable of doing that, we would have. The only reason we did this is because the instruments are based on the height, right? So if it's set up to be this high, that's telling you the radius that it can measure, right? If I'm way up high, then I can get a bigger area. See what I mean? But the grass canopy is not high, so I have to equilibrate it to that too. So that's why about 50 acres is all I can really measure at one time in this kind of an experiment. But we wanted to get the seasons, so we split it into 4 places in order to get the seasonal grazing differences. And that's why it ended up that way. If I could have done it differently, I would have, to make it more like what he normally does.
But are you confident in your assessment then of how everything measured out? If it would be, you think it would be the same in a day or day and a half as 2 or 3 weeks, a month? Some other ranchers are doing it harder and so forth. Do you think that's comparable?
Well, it's all a matter of the leaf area removal, right? So if that's the factor that we measure, and that's one of the reasons we do that. We measure how much their estimates of their consumption, how much forage did they take off. We measure the leaf area that they removed. If a rancher that's putting it out there for 2 weeks on 200 acres is doing 50% leaf area removal, then it would be comparable.
And then just to add to that, if you want to do a contract with the company, you know, there's the price range they use on what they pay for carbon is based on the quality of the carbon, and you would get a higher score and a little higher price. Probably the more managed your rotation was with less time, you know, like if you were a 2-day rotation, you would get a higher quality carbon payment than it would be if you had like a 6-week rotation.
So I have a question about, is there a market, are there companies that are paying for this on rangeland? I know
There are
companies that are doing it on no-till, you know, cropland, because I have relatives who have cropland and they're getting carbon payments.
Yeah.
But this is completely different. So what companies are there out there?
There's 2 or 3 of them that do rangeland, and as far as I know, there isn't any company that does both.
Okay.
You know, cropland and rangeland, but they are working on it. I know they are. And Grassland Carbon is the one that I had the offer from, and they may expand into cropland too. And Indigo on the other side, that's one of the major players in cropland brokering of carbon credits, are interested in rangeland in the future too. So I would guess someday that will kind of mesh together where, you know, one company will do both of them.
And so are they using your technology to measure the carbon? Because with the no-till, that's so much, you know.
Yep.
So,
Well,
They go ahead. They do want to look at our data when we're, you know,
they are
project
interested.
is complete.
So this idea of looking at the effect of managed grazing on the carbon is relatively unknown. So when I talked with them, with Lewis, about their technique for estimating annual carbon uptake, they said they're going to get back to me with how they do it, but they use the infrared and they use historical flux tower data. So that image I showed you with the map, a friend of mine used years of flux tower data and infrared information in order to estimate that and map those, which is very likely the kind of data set that these people are probably using. So what we're proposing here is improving on that, basically, because in those cases, there was no management factor at all in those flux studies. Yes.
So, could there be a correlation, or would this be a subject to another study to see, how that would be valued to the cattle themselves, like their health or their bulk, or, whatever, economic value, would that be something maybe?
Yeah, there's a value to that, and I think some of us already know, when past rotation, because you get a lot of, you lessen your fly control each time you move to a new pastures, because you don't have, they haven't been there before, they have clean ground and everything, and there's other benefits to it too.
And I think there's been work out of stations in Colorado or Wyoming looking at rotating it and actually calculating beef and gains and things like that. I think, for just that component. So like in any study, you want to do it all, but you can only do. So I think some people have focused on that, the rotation and cattle piece in other areas. Yeah.
So how many years of testing before we can get to a point where we can say we're 80% accurate on the carbon capture versus our climate situation in North Dakota?
Well, after the first year of data collection, I'm going to work up a whole year of the carbon budget, right? And we're going to put together a paper and that'll give us that first year carbon budget. The second year, the carbon budget will be different because the weather will be slightly different. But what we're looking for is what effect did that grazing have? And will that effect of grazing, will that be the same for both years, right? The modeling of being able to scale up and actually identify way over here, in Williston, what that ranch is doing, that's going to take those 2 years of data to support that model to do that over there. So we're good so sometime in 2024, we will have a pretty good idea of how this managed grazing system is influencing our sequestration, right? And then it's just a matter of collecting more data to see how that changes or doesn't change, and then scaling up. Does that answer your question?
And then, yes, it did. And then my next question is going to come on grass varieties. Do you see that being an influence in this? I know we were based on native grass, but we have a total different from Lewis's ranch by McKenzie versus my ranch at Dunn Center.
Yeah.
Is probably another 20 different grassland species that are growing.
Yeah. Well, the fundamental thing we focus on is leaf area. So your species change, the leaf area changes. That's first cut, a for sure factor, right? From there, the details of if you have more warm season grasses and things like that, those are also involved, I'm sure, but it's to a lesser degree, because it's mostly from what we know already. What we know is mostly dominated by things to do with weather and the leaf area and the soil. So versus the particular plant species, but that could be teased out over time, but it's not typically considered a primary factor as long as you got leaf area.
As we move forward now, what is your visionary on what the climate's going to do and how this is going to react over the winter?
And depending on how the weather is over the winter, now that because I've got another 6 months to go before I get my first year. So what I'm seeing right now, or when it was snowing there at the end of October, is very, very, very minor release, right? When it's completely snow covered, that's what you call high albedo. We see it in the measurements. We know we're not bringing carbon in. We're just releasing a little bit. Now, other studies have said, well, if you get in 1,000 carbons over the course of the growing season, you might lose 800 in the course of respiring, right? But all these conditions depend. So where I'll see most of the release of carbon is going to be in the spring. And I would not expect the release of carbon over the next 6 months to overwhelm or be greater than the carbon that has been taken up over the growing season. The key thing is going to be, will there be a difference between the two treatments? But in general, the reason we have grasslands is because there's always more coming in than is going out.
Louis, I have a question for you then. On the contract that you kind of looked at and then studying a little bit probably, what I've read in some of the farm magazines that is being offered in Iowa and Ohio, and I believe Nebraska was the other state where some of these carbon capture on grasslands is being offered. The longest term I've ever seen in that is 3 years. Are you aware of anything different?
Most of these are 10 that I looked at.
Okay.
They're 10 years, the way this company explained to me is they come in and they do a core sample benchmark when you first start. And then you know what your rotation is, they work up they have some analytics that will give them close to what they think your carbon sequestration would be. And then they will come back in 5 years, do the same cores again and see what the change in the carbon was. That's the way I understand it. And then after that, they go on to it. Most of these are a 5 year with a 5 year option at their pleasure or whatever you can call it.
And for whatever it's worth, there was a study that we did, a soil study, where we looked at the soil cores over time, and in a ranch in Williston, where he had restored an area from cropland to grassland. And we calculated that it was about 1,000 pounds per acre per year that he sequestered as a result of that restoration, compared to if he wouldn't have restored it at all. So that 1,000 pounds, right, is a pretty strong number that's being sequestered that you can get with these perennial grasses. He did a native mix through Jesse Becker's work, and managed it with rotational grazing. And during those years, there was a lot of drought too. So that's the kind of number that you might see in Western North Dakota based on what we've observed in a restoration project like that. We'd love to put these out in other areas, of course, but.
And there's no water sampling done with this at all, right? I mean, as far as quality of water from runoff with that at the end.
I'd love to, but no.
Yeah.
No. So basically, if people talk about, carbon dioxide exchange and carbon dioxide coming into the system, right? And they say, well, corn takes a lot of carbon out of the air and grass takes a lot of carbon out of the air. The whole key is, what do you leave behind? Okay, you can take a lot of carbon dioxide out of the air through photosynthesis, but if the more you harvest away, the less is kept there. So if you want to keep it there, you've got to take that into consideration. So if that's an important point that we're doing here. We're saying how much came into that system, and then how much did the cattle take? How much did the cattle deposit? If this were a crop field, then we'd be saying, how much did we harvest off? So then we know what's left behind. So that, just from an educational standpoint, I just want everyone to leave here understanding that part, if you will.
Yes. So, Louis, you said that you've been intensively rotating your cattle for a while.
Yes.
Correct?
Mhm.
So the pasture you guys used as your control had already been, over the past 15, 20 years or so, been rotated
Yes.
in most circumstances.
I purchased it about 4 years ago.
Okay, so 4
yeah, I've
years.
only got that data from that time.
Okay.
Yeah.
So I was wondering if, I guess in those 4 years, had you been able to change your nutrient cycling to the point where maybe those plants, the species have changed a little bit, and the diversity has changed a little bit to the fact to where maybe they're used to being grazed multiple times in the year, and they are producing more leaf area Whereas if it was something that had been where the cattle out in May and even till September.
Yeah.
That maybe they're already producing more.
Well, I'm sure I've already got some gains on that, the 3 years that I had before we did this project.
So
Compared to what it was before.
I'm just wondering if it would have been this would have been just once out grazing throughout season long grazing, do you guys think you've seen a bigger change in?
My guess would be yes, but
I would guess, but Lewis hasn't done it that way, so, we just used what he had. And we did get, we do have the species inventory and, around those units, and they are relatively comparable. So we're not seeing wild differences between them in terms of the functional groups, forbs, C3, C4 grasses, even the amount of manure that is in both, that is left behind, over the years, you can, similar amount of cover. So it was they're not perfectly exactly the same, but they're as close as we could get. So, thank you very much. Appreciate your time and thank you for being so.